last time we did three principles. So now you're going to move to number 4. So we've done the one for multiplication, now you're going to do the one for division. And what does it look like? Please don't write until you have done when you write. Let's say x equal to 5, x over 5 equals, let's say, n. Now, how do we are asked to solve for x? We solve for x in terms of n. So how do we make x the subject is to look for solution. Now let me look for the multiplicating inverse. If you have questions when I'm done, you can ask. Now let me look for the multiplicating inverse of divided by 5. You know, when we did additive inverse like plus 5, additive inverse of plus 5 is minus 5, right? Then we did minus 5. The additive inverse of minus 5 is what? Plus 5. Then multiplicative inverse of times 5 is what? 1 over 5, right? Yeah. Now we have divided by 5, and divided by 5, this is actually x times 1 over 5. Are you guys aware? Yes. Good. So there are two ways of doing this. So I'm going to do the first method and the second one. So the multiplicative inverse of 1 over 5 is what? 5. It's 5, right? Good. So I'm going to use it to multiply both sides. So if I do that, x will be left, right? Then I have 5 what? N. So that's the first step, method. So or the second method, don't write it. The second method is x over 5 equal to n. Okay? Now this is actually x over 5 equal to n over 1. So do what we call cross multiplication, right? Good. So we also cross multiply x and 1 we multiply, right? And 5 and 1, n, which is x equal to what? 5n. So there's a third method, the third way of doing it, which is x over 5. So don't write it, just be patient with it, let me be done with it. X over 5 means x divided by 5, right? Now what you do is you cross it to the other side. So whenever plus crosses equality sign, it becomes minus. When minus crosses equality sign, it becomes plus. When times crosses equality sign, it becomes division. So when division crosses, it becomes times 5. So that's 5. Okay, so don't forget, now you are numbers always form the 4 letters. Okay, you can write. So number 5. Now we've done addition, subtraction, we've done multiplication, we've done division, right? Good. Now division has two aspects. One, what you're looking for is up. And what you want to use as a subject is the numerator. There's a second part of division where what you're looking for is the denominator, which is number 5. Which is, for example, 5 over x equals to 10. Now this is slightly different from number 4, right? In number 4, x was what? Numerator, y5 was what? But now we have x as our denominator. So how do you resolve the problem like this? First of all, you invert both sides. Don't forget, we are still making x our subject, invert both sides. And that means take the x up and take the 5 down. And anything you do on the left hand side, do it on the right hand side. Don't forget, m is m over 1. So it's not 1 over. Yes, it's called reciprocal. Yes, reciprocal of what you are, or the inverse of what you are. So you just invert it and get it. Then the next thing you do the normal cross multiplication. You get okay, there's no need to use n to multiply the x. can still do it if you want to, but the faster way of doing it is to multiply only to the right. That's from the bottom to the top. That means I will get x equal to 5 over n. It's just a short form of cross multiplication. That means ordinarily I'm supposed to have xm equal to 5, right? But because I don't want to start dividing both sides again, no need for doing that. Just leave x where it is. You use only 5 and yes, and you get this.
So you have to see
no, you're not reciprocal. Okay, now I have number 6. Now, for number 6 and number 7, number 6 will be about pairs, number 7 will be about roots. Now, if you know what I mean. For pairs, for example, x raised to power n equals to, let's say, n. And we have to solve for x in terms of a and n. Okay? So that means there are no figures here. Is a part. A part is also called an index or superscript or exponent. So take one of those names. Part, index, superscript, exponent is also called degree. So this part now, we are going to eliminate it. I will teach you how to eliminate the part. Why I'm using a letter is to give you a principle that will help you eliminate any number. Stop. Princess, let us do some stop. You see now, this is the most important part, and I can't afford anybody sleeping at this point. Stand, yes, Princess, stand. I can't afford to lose you now because I'm taking you to the difficult aspect of this. So when you see any number like 2, 3, 4, 2 is square, right? When you say cube, right? Yes. 4 raised to power 4, raised to power 5. How do you eliminate? So I'll teach you what to do with this. Then with this principle, you can now apply it on any number they give to you. You need to eliminate the power. So solution. What's the solution? X raised to power n equals to n. So what are you supposed to do on both sides? But what I'm going to teach you is to turn on to apply anything you're doing on the left hand side, also do it on the right hand side. We go over the left hand side of the division, and we go over the right hand side. So why is the left hand side? Because my left hand is here, and my right hand is what? Here. Okay. So let's go. How do I eliminate A? I'm going to use the multiplicative inverse of A to exponent both sides. When I exponent, I'll put it as a part, not just to multiply it. When we are doing division and multiplication, yes, I'm going to use it as a part. So who can tell me the multiplicative inverse of n? Answer that question as it is. What is the multiplicative? I thought multiplicative inverse. So what's the multiplicative inverse of just n? We learned yesterday. Good, that's principle. Principle will work anytime you apply it. So we have x raised to power a, everything raised to power 1 over a equals m raised to power 1 over a. Now some people wondering where's 1 over a coming from? She has already answered it. That's the multiplication inverse of what? A. So as I said, raise both sides to the power of that multiplication inverse, and that's what I just did. You're confused. Let's see. Is it because of the write-up or you understand what I just said? But just like the writing, the way I wrote them is looking confusing.
What do we use the inverse for practical?
Is that? Now the principle is anything you do here, do it here. Simple. I can now somebody is asking why bracket here and why no bracket here. There is no bracket here because I'm raising only a 10 to the power over a. But there is bracket here because there are 2 terms. You always bring in a bracket when you have more than 1 term. Like now, for example, I have x and I want to raise it to power 2, for example. I don't need a bracket. But if I have x plus 3. There are two terms. I want to raise all of them to the power of 2. I have to bring in a bracket and raise all of them so that the power 2 can affect the two of them. Do you understand? So it's called an expression. Yes. Although one term is also an expression, 2, 3 terms are an expression. So we have just a singular term and double and poly. It's called polynomial when they are many, or if it's one monomial. If it's just one monomial. Okay, so we can now use what we call power law to eliminate this. We've got laws of indices, right? So A times 1 over A, then M is power 1 over A. So this can be this over 1, right? Only x will be left, and you have m raised to the power 1 over a, which is equal to the square root, is a law of indices, and L will be left outside. Now, this is a law. If A were to be 2, that means m raised to the power 1 over 2, then it will be square root of what? M. If A is 3, then it will be the cube root of m. That's if this A is 10. Do you understand? So when I say cube root, it means cube root of Mr. Mama means Mr. Mama raised to power 1 over 10. When I say square root of Mr. Mama, what does it mean? Mr. Mama raised to power 1 over 2. When I say fourth root of Mr. Mama, it means Mr. Mama raised to power 1 over 4 root. That's it. Alright. Okay, number 7. Number 6, we dealt with powers. Number 7, we are going to deal with roots. And in a case like this, what do we do? Now, this is the, allow me, this is the, now if it's 2 that is here, we call it square root. If it is 3 that is here, we call it cube root. If it is 4 that is here, we call it fourth root. So it is any letter, what fifth root. Now if it's sixth root, now it's the same principle. Now if it's A, listen, or any letter, who can tell me what you call it? If it's B. No, not just B. Yes, you put the edge. So it's called A root, okay, of X. That's what it's called. Okay, so I have to do that. So this implies this. Now we are looking for solve for X in terms of A and M solution. Okay. So don't forget that A root X means X raised to the power 1 over N. Laws of indices. This means this. If F is to be the square root, that's 2. You know when you square root, you will not write the 2, right? Yes, it's 1 over 2, right? When it's cube root, it's 1 over 3. So this is what it means. Now we are going to apply the same multiplicative inverse principle, where we are going to apply the multiplicative inverse of the power on both sides by raising both sides to the power, which is, so let's get the multiplicative inverse of 1 over A. Multiplicative inverse of 1 over A, what? A over 1, which is, what is A over 1? Good. So X raised to the power A over 1, we now raise both sides. Yes, this 1 over A is still there. Because anytime you're doing what you want to do, don't throw away what you already have. Work with what you already have. So now I want to put in the power now. I want to introduce the multiplicative inverse as a power, which is raised to power A, right? Raised to power A. I don't know if you got this one. You got this one, right? Good. So this now multiplicative inverse are now raising both sides, using as a power on both sides. the same equation, the same terms. And now what do I have? Using power law, this and this will multiply, right? Good. So I have only x left, then m raised to power n. So that's the end of our 7 basic equation principles. So see you on the next.